Good afternoon, everyone. So I'm actually between you and your lunch. So similarly, GalaxEye is between rocket and the space applications. We precisely built satellites. To quickly introduce what we do is we're building this next generation Earth observation satellite, which we really started back in 2021 at IIT Madras. And from there, it's been a 4-year journey of a lot of R&D that went on to building sensors for drones, aircrafts, HAPS, and now finally getting into the satellite. We're almost at the cusp of launching this satellite. We almost completed our satellite development in September 2025, currently in the flight model assembly, and will be launched in Q1 2026. June onwards, the satellite data will be available. This is how it looks like, and I'm very fortunate to be presenting in front of Dr. Somnath, and he has been the bearer of the office where this satellite is being tested. So you see the left top image, that is where the satellite is going through the vibration testing, the deployment of the SAR antenna, and so on and so forth. This is just getting started. This is just part of the larger constellation that we are trying to build. By 2029 or 30, we want to build a 10 satellite constellation that will offer us a 3-hourly revisit on a global level. With first satellite, we'll be at around 5 to 7 days revisit. But why are we doing all of these things? This is the question that we asked back in 2021, and I don't come from space. I built Hyperloop at IIT Madras, then went on to do some of the jobs. And that's where I figured out that, satellite, it has 3 applications. You build a rocket, you build anything, it has 3 applications: communications, navigation, and Earth observation. Communication, as Starlink is blanketing the Earth, will be real very, very soon. And even, we'll see more and more comm satellites coming from India. Navigation is also very commoditized. We use GPS on a day-to-day basis. You either use Uber, Ola, Zepto, Zomato, you use GPS. But we don't use satellite imagery on a day-to-day basis as a commodity. What is the reason? The reason is Earth's landmass at any given point on Earth is covered by clouds, up to 70%. That doesn't let us build downstream applications at scale. And today's technology, we talk about many technologies: multispectral, optical, hyperspectral, synthetic aperture radar. All of these technologies solve the problem in half. Like if you see optical, multispectral, or hyperspectral, if there is cloud, it can't see through it. And we are a tropical country, and we see more clouds than other global countries. Radar are very useful. It can penetrate through clouds, but it's like X-ray. You see white dots, black dots, and you need experts in loop to understand that imagery. And there are existing imagery options, where you come and fuse them together to say, I'll fuse a multispectral and a radar imagery together and use some AI as a black box and whatnot to solve this particular problem. But unfortunately, that can't happen because this leads to newer problems. Like in the top image, there's a ship in an optical image. The ship has gone in the radar image. These images are not temporally matched, which means both the satellites of optical and SAR are not coming at the same place at the same time today. And hence, you have a temporal mismatch, the perspective mismatch, and inconsistent change detection. And decisions, definitely should not wait for bad weather, fragmented data, or false positives. What if you could combine optical with SAR that can give you the availability of SAR and intuitiveness of the optical? That is precisely Mission Drishti. This is world's first, not just India's first, world's first multi-sensor satellite that is putting together an optical and SAR, synchronously fusing, looking at the same area at the same time. We offer a range of products. We actually only offered the mid one, which is data as a service, building a constellation and sharing data with the users of where you want. But with the geopolitical environment changing, we understood that there is sovereign requirements of building satellites. We also understood that there are requirements to do AI-based analytics because data doesn't sell for itself, it's always the insights. So what we thought is to build an app store for Earth intelligence. And the GalaxEye constellation becomes an infrastructure where you can build an app related to agriculture, defense, utilities, and so on and so forth. This is an evolving market. $2 billion is just a number that, if you add cumulatively the revenues of all the private satellite companies around the world. This is not counting the imageries that is disseminated by the government organizations. But it is evolving, and it'll go up to $8.5 to $10 billion moving very forward. And these are all the applications that we're looking for. Now, one such application is what we thought we'll build ourselves. This is for defense and intelligence. It's called GalaxEye's Hypernova. And I'm very proud to say that this was actually used in the conflict very recently by our defense forces. Thank you. We'll not go into the details of it, but of course for the sensitive reasons. But this is something that uses fusion as the core technology to make sense in the bad weather and during the night time. One of the quick examples is on the right, on the left, you see an optical image where you can annotate properly and see the ships. The second image from the left is SAR, which is very hard to understand, whether there's a ship or a submarine or a reflection of something. So what we did for the users is fuse them together to give them an intuitive understanding on what has been docked on the board. And the fourth that you see is basically the change detection between optical and SAR, which allows users to not go anywhere, not go everywhere in the image and look at each corner, but only follow the reds and reach the change detection. Like we've heard in the keynote speakers, aspiring India needs to own its own eyes in the sky. And we are prepared to do that. We started at IIT Madras at Professor Satya's lab with a 250 square feet small lab. And now we've just started our facility near the airport in Bangalore. It's a 50,000 square feet facility where we'll be building India's first and largest satellite which has SAR, and world's first satellite which has SAR and optical both on the same satellite. It will also have the mission control center, the labs to build the satellites, and a 150-member, 50-seater space to do the same. Today, we're 100+ members strong. People came from different backgrounds. Some are ex-ISRO who probably have contracted with ISRO earlier. People came back from companies like ICEYE, which is based in Finland, who are of Indian origin. And we are increasingly seeing people studying in the US or working for a US-based company coming back and joining us. We also have 6+ patents which have been filed globally, as well as in China, just for fun. We did that, but it is filed globally. We also feel, we're very fortunate to pick a few accolades on the way. We also spoke to Prime Minister, Honorable Prime Minister, for around 20 minutes on his personal podcast called Man Ki Baat. It was a very interesting time for us. And this entire thing has started at IIT Madras with 5 folks dreaming to build a space company out of India, despite so many challenges. But something where we want to do is build world's first and not just India's first. We don't want to make things cheaper in India, but we want to make something which is world's first and start from India to give India a soft power across the world. Thank you so much.